Welcome dear students to video number 4 for standard 9 geometry chapter number 5 quadrilaterals. In the previous video we discussed these properties of a parallelogram and we proved these. Let us continue. Prove that every rhombus is a parallelogram. Given information is quadrilateral ABCD is a rhombus. We have to prove that this same quadrilateral ABCD is a parallelogram. Now, according to given information, we know that in a rhombus all sides are equal. Therefore, segment AB is congruent to segment BC, is congruent to segment CD, is congruent to segment DA. Given information. And on the basis of this, I can just interchange a few sides and write side AB congruent to side CD and side BC congruent to side AD. If you see, these are opposite sides. And opposite sides are congruent. Therefore, I can say that this quadrilateral ABCD is also a parallelogram. The reason opposite side test of for parallelograms. Now we move on to practice set 5.2. Question number 1. In the figure, quadrilateral ABCD is a parallelogram. P and Q are midpoints of side AB and DC respectively. Then prove that quadrilateral APCQ is a parallelogram. According to given information, this particular quadrilateral ABCD is a parallelogram. Therefore, side AB is parallel to side DC. Opposite sides of parallelogram are parallel. That is, if AB is parallel, that means AP is parallel to CQ because these are part of the bigger sides. So we have AP parallel to CQ. The reason A''B' and C'Q''D. I am naming this as statement 1. And I have AB is equal to CD. Opposite sides of parallelogram are also equal. I am just multiplying on both sides by half. So I have half AB is equal to half CD. But half AB is AP because P is midpoint of AB. And half of CD is CQ because Q is midpoint of CD. Therefore, I can substitute and I write AP is equal to CQ. This is my statement 2 and this is my statement 3. So my reason would be from 1, 2 and 3. I can write AP is equal to CQ and I am naming this as statement 4. So I have in quadrilateral APCQ, AP parallel to CQ from 1 and AP congruent to CQ from 4. So from 1 and 4, I can say that a quadrilateral is a parallelogram if a pair of opposite sides is parallel and congruent. Therefore, quadrilateral APCQ is a parallelogram. Hence proved. Question number 2. Using opposite angles test for parallelogram, prove that every rectangle is a parallelogram. So I have given quadrilateral ABCD is a rectangle. I have to prove that this rectangle is a parallelogram. Let us start. This quadrilateral is a rectangle. Therefore, angle A is equal to angle B is equal to angle C is equal to D is equal to 90 degrees. So these are angles of a rectangle. And if all angles are 90, I can say that A is equal to C, both are 90, and D is equal to B. This is also 90. So this pair I can say is equal and this pair is equal. If you see, these form opposite pairs and we know that in a quadrilateral if pairs of opposite angles are congruent, then I can say that that's a parallelogram. So hence a quadrilateral is a parallelogram if its opposite angles are congruent. Therefore quadrilateral ABCD is a parallelogram. Hence proved. Question number 4. Prove that quadrilateral formed by the intersection of angle bisectors of all angles of a parallelogram is a rectangle. So, I have this quadrilateral, which is a parallelogram, say quadrilateral ABCD, and its angle bisectors are drawn. You see these dotted lines? Yes, these are angle bisectors. And these angle bisectors meet each other at these points and they form another quadrilateral, quadrilateral PQRS. We have to prove that this quadrilateral PQRS is a rectangle. Let us start. Given information is quadrilateral ABCD is a parallelogram. So I can say that angle ADC, this angle, plus angle BCD, this angle, is 180 degrees because they are adjacent angles, and we know that adjacent angles in a parallelogram are supplementary. Now I am just multiplying that statement by half. So we get half of angle ADC plus half of angle BCD is equal to half of 180 degrees. Now if you look over here, angle ADC, half of that is PDC because this is an angle bisector. PD is an angle bisector. So half of ADC is PDC. Similarly, half of BCD is PCD. PCD again because PC is the angle bisector. So this is my statement 1, this is 2 and this is 3. So from 1, 2 and 3 I can say that PDC plus PCD is equal to 90 degrees. See, look at statement 1, 2 and 3. Half ADC, so that is PDC. Half BCD, that is PCD. And half of 180 is 90. I'm going to name this as statement 4. Now in triangle PDC, this triangle PDC, angle PDC, this angle, plus angle PCD plus angle DPC is 180 degree. Sum of measures of all angles of a triangle are 180 degrees. And I know the addition of these both, that is 90. So 90 plus DPC is 180. From here I can find DPC as 90 degrees. This angle DPC, that is S, I can also call this DPC as SPQ because D dash S dash P and P dash Q dash C. So SPQ I found as 90 degrees. I'm going to name this as statement number 5. Similarly, in this triangle BRC, I can say that this angle S, this angle SRQ as 90 degrees. Just like how I found this angle, in the same way I can find this angle as 90 degrees. This is my statement number 6. And also I can find this angle ASD as 90 degrees in this particular triangle. Just a minute. In this triangle ASD, I can find this angle as 90. And this angle is vertically opposite to PSR. So if this is 90, PSR is also 90. And that is my statement 7. Similarly, in this triangle BQC, I can find that BQC angle is 90 degrees. And angle BQC is equal to angle PQR, vertically opposite angles. So PQR is also 90 degrees. That is my statement 9. So from statement 5, statement 6, statement number 8 and statement 9, I can say that angle SPQ is equal to angle SQR is equal to angle PSR is equal to angle PQR is equal to 90 degrees. That means all these angles P, S, R, Q, these are 90 degrees. When all these angles are 90 degrees, that means this particular quadrilateral is a rectangle by definition. Hence proved. My dear students, this is all for now. We will meet in the next video. Till then, thank you for watching. Have a nice day.